Okay, hey guys, so we are going to give this a go. We are going to do a little recap on balancing equations. I know it's been a little bit, so just a little reminder, we balance equations because we follow the law of conservation of mass. So we need the reactants side to equal the product side in amount of atoms. So our steps in order to do so are the following. We always want to balance your big atoms first. So basically that means anything except your hydrogen or oxygens. Step 2, we're always going to balance our hydrogens, and then we always leave oxygen atoms for last. So to give this a go, we are going to try an example. Okay, so bear with me as I work to get technology to cooperate with me. So if I am looking at my equation, my chemical reaction, I am going to kind of divide this guy in half, okay? Okay, so I am going to count how many irons I have. Oh, that's awfully big. Let's try and erase that again. All right, let's try once more. All right, so if I am looking at iron, I see that I only have 1 on this side, and I have 2 oxygens, and I have 2 irons on my right side, and I have 3 oxygens. So nothing is balanced basically means I have uneven numbers on either side. So I'm going to focus on my big guys first. So iron is 1, iron is 2. So that means I'm going to change the guy on the smaller side. I can only change numbers by adding a coefficient. So if I put a 2 in front of that iron, it changes my 1 iron to now 2. So these guys are now balanced, but my oxygens aren't. I have a 2 and a 3. Oxygens often like to do this. This is what we call the odd-even rule. So I am going to look and say 2 and 3. You know that means I could get 6. So if I put a 2 in front of here, 2 times 3 is 6 oxygens now. And that means that I need a 3 on this side. And 3 times 2 is 6. So my oxygens are balanced. But the thing is, my irons aren't anymore, because when I put this 2 in front, I actually changed my amount of iron. So 2 times 2 is, I now have 4 here. Okay? So now I have to go back. I can always change coefficients. And this 2 now needs to become a 4. So I can always check. So I go irons 4, balanced, oxygen 6, balanced. I can now move on to my next question. Okay, let's try the next slide. Yep. Now to cut this in half. So I have 1 carbon. I have 4 hydrogens. And I have 2 oxygens. Now on my product side, I have 1 carbon. I actually have 2 oxygens here, and plus 1 is 3. I like to personally keep these guys separate, so as I change one, I can change my numbers. I don't have to count the total all over again. And then if I look at my hydrogens, I have 2. Okay, so start off with your big guys. Carbons are balanced, hydrogens are not. I have 2 and I have 4, so that means I always change my smaller one. So I need a number to multiply 2 by what gives you 4, so 2 times 2 is 4. And when I change that guy in front, coefficient, so 2 times 2 is 4, but now I actually have 2 oxygens there. So now I have 4 total oxygens, and my total has to be on this side equals the total on this side. So if I have 4 on this side, that means I can put a 2 in front of here. And this now becomes 4. And 1, 1, balanced, 4, 4, balanced, 4, 4, balanced. This question is good to go. Okay. And then we have this guy. If you're feeling confident at this point, you can pause the video and try it on your own and then check your answer. I'm going to keep going. So we have SN. I have 1. Oxygen, I have 2. And hydrogens, I have 2. Tin, I have 1. Notice my hydrogen comes next. I like to put my elements that are the same across from each other for ease of balancing, just so I can look across. And oxygen, I have 1. Okay, so that means I have my tins are balanced, my oxygens are not, but I'm going to leave it till last. My hydrogens, okay, so it means I get to go to my oxygens. 1, 2. If I put a 2 in front of this guy, my oxygens are now at a 2. But when I put the 2 in front, it also changed my hydrogens, so now this is a 4. And so now I have to go back and say, okay, my tins are still balanced, my oxygens are still balanced, my hydrogens are not. So I'm going to put a 2 in front of the hydrogen, and I should have 4. So balanced, balanced, balanced. Okay. Now, when things get tricky, sometimes you kind of get in circles and you go, okay, things aren't making sense. So when you have an odd number on one side and an even number on the other side, try doubling all your coefficients. So that's all your numbers in front. So if this was a 2, you double it to 4. If this was a 3, you double it to 6. If this was a 5, you double it to 10. So whatever coefficient it is, you double it, recount everything, and then you always leave your oxygens till very last, and you'll see how many oxygens you'll need total. I'll give you an example on that one. The other little trick is keep your polyatomic ions intact. Okay, so that means if you have NO3 on the one side, you're going to want to, and it exists on the other side, you're going to want to keep these as a unit. It makes your life a lot simpler. In that case, sometimes it doesn't let you, so you have to split it up. But if you can, you can. So we will do a couple more. Once again, if you want to give these a go, pause and attempt away. So I'm going to cut in half like typical. I'm going to start counting. Carbons 3, hydrogens 6, and oxygens 2. Okay. Carbons 1, oxygens, oh, that doesn't line up. Let's try that again. All right. Oxygens, I have 2 places, so I have a 2 and I have a 1. And my hydrogens are 2. Okay, so my carbons don't match up, my hydrogens don't, my oxygens don't. So let's start with my carbons. I'm going to put a 3 in front of here. And now I have 3 carbons. But when I change my carbons, I also change my oxygens. So now my oxygen is now 6 here. Okay. And then if I look at my hydrogens, I have 6 and I have 2. So if I put a 3 in front of here, 3 times 2 is 6. So balance, but my oxygens have also changed now. So 3 times 1, so this is a 3. Okay, so now I have 9 on this side, but 2. So see that odd even rule? So I am going to double everything. So double, leave this oxygen O2 for last, double, so this 3 becomes a 6, and this 3 also becomes a 6. So now let's go back and count. So my carbons are no longer 3. My carbons are now 2 times 3 is 6, and 3 is now 6, so carbons are good. My hydrogens, 2 times 6 this is a 12 here. My hydrogens here, 6 times 2, this is a 12. And now let's count my oxygens. This guy we're still leaving at 2. 6 times 2 this is a 12. And just erase that so it doesn't get confusing here. Okay. And I have 6 times 2, so it's a 12. And my other oxygen is 6. So now I have a nice 18, and which means 2 times what gives me 18, which is a 9. These are often the trickiest questions you will end up getting. Okay, so let's try the bottom one. You will notice you're going to see a polyatomic OH, that's your hydroxide. This is often why actually you'll see me write water as HOH. Okay, I mentioned that in class before, but it's another way to write it, and this is actually the reason why we write it this way. All right, so let's start counting. Calcium, there's 1. Because we're going to keep our hydroxides together, I'm going to count it as a unit. And notice there is 1, but because there's brackets around, it actually is telling us that there's 2 of them. 1 hydrogen on its own, and I have 1 chlorine on its own. Calcium, I have 1. Chlorine, I have 2. Hydrogen on its own, there's just 1. And my hydroxide is staying together as 1. Okay, so balancing. Calciums are balanced. Hydroxides are not, but I'm going to check my chlorines first. So I have 2, 1. So I'm going to put a 2 in front of here. Let's see what happens. So now I have 2 chlorines, and I also have 2 hydrogens. Okay. My hydroxides are still not balanced. I need 2 on my right-hand side. So I'm going to put a 2 in front of here. This means I get 2 hydroxides, and I also actually now have 2 hydrogens. So if we're checking our balancing, which of course we are, calcium, just double checking, hydroxides, hydrogens, and chlorines. So all are balanced. Okay. And I am going to give you this one as well. If you're feeling confident again, obviously feel free to go and attempt to move these on your own. This is an example of a polyatomic, so polyatomic ion right there. But you'll notice, so it is on this side, but because you also have carbon and oxygen here, and there's no plain carbon and oxygen on the original side, you have to split your carbon and oxygen up in order to handle it properly. This goes for the case as well down here. There's NO3 in this acid here, and it stays, but it also shows up here, so we have to split these ones up. And I am going to just pause there and leave it at that. If you have any questions, please feel free to put them in the comments section of Google Classroom.